Yeah, so I'm just putting this. So, conjugacy classes of Sn and also An. So you have any specific question in this?
No.
No?
Just to find out the classes.
Okay, just to find out the conjugacy classes. Okay. So let's
In a form of like S and N could be anything.
okay. So we are starting with this n, natural number obviously, because there is something called S infinity also, which is sort of very interesting. Yeah, recently, at least in my studies, but yeah, Sn. Let's see. So this is n is a natural number, and Sn is, I'm not defining. So Sn, both of you know what is Sn? Yeah, do all of us know?
Yes.
Okay.
Yeah.
All right, perfect. So conjugacy class. So conjugacy class is a concept which is associated to elements of a group. Okay. So I'll denote it by Cj. Fine. Cj of G. The G is an element, but in our case, let's denote it by sigma because it is a permutations. So what is this? It's very important. This is, okay, I don't want to use tau also. What will be a good notation here if I want to conjugate? Maybe I'll just write tau 1 inverse, sorry, sigma, because tau is usually reserved for transposition. So I don't want to use that also. You see, notation, choosing the notation wisely is very, very important. Okay? Otherwise, writing mathematics will not help you to gain insight if you don't use proper notation. It will actually confuse you further sometimes. Yeah. Where sigma 1 is in that group wherever you are. Okay. And I I think finding conjugacy classes of an, I don't know if this is your question, but finding conjugacy classes of an is a non-trivial question. But if you, we will approach it. I don't mind doing it. In fact, I love to do it. But we will see. Yeah, there is, the theorem actually says that there is only one conjugacy class in an. Okay, but we'll talk about it. It's very related to that PSLN thing which I was doing last day. I mean, I won't get into it, I promise. But
Actually, I was doing, but I can't find any.
you cannot find
That's
any.
why.
Okay. So the point is that these two groups are both simple. Okay, I mean, for n bigger than 5 or something, below that we don't bother. They are very small numbers. You can calculate. Okay, so for n bigger than 5, there is no conjugacy class, and that is the same thing as being simple. You may not see that immediately. I will talk about it little bit. Okay, yeah. And the proof of this two actually is very similar. I mean, if you do the algebraic proof, and I promise I won't get into geometry proof. Yeah, I actually don't know, but I would like to read and do it simultaneously, but we will not do it. Let's see. Okay, but for Sn, it's a lovely classification is there. Yeah. Okay, so this is conjugacy classes. So conjugacy classes are useful for several purposes. I will mention one in the sense that all these elements are alike, right? They are very similar to each other. We saw that last time also, right? When we were taking one particular inversion and conjugating it with others, they were all inversions and they all had a similar, they were just coordinate shifts, inverting about a different circle. So in the same way, all these permutations are very, very similar. Okay. But the question is to describe Cj, right? we want to describe CG. So what are all the permutations which we can get by starting with one permutation and conjugate? Okay, right. So first of all, simplification. First step will be a simplification, as I can tell you just basically from, I'm saying all this from memory mostly. First, a simplification is that it is, first I'll state the claim so that even while I'm proving, you may just convince yourself that it is correct even without a proof, which is very important. Because all these small lemmas, you don't need to know the proof of them in detail. You just need to, over time, just you'll know that you can prove. It is enough to look at cycles. Is it clear what I mean by cycle?
Yes.
Yes.
Okay. Yeah. So this language is again something which you know, and that's why we are, you see you are kind of sort of standing on that to build to look higher. Why is that so? Because suppose that it's a permutation and you want to, basically because conjugation is an automorphism. It's a very nice thing. So if you write this as product of cycles, what's a good notation for cycles? Should I write C1, C2? This is like this. Some things will be filled inside. I'm not writing it. Okay. And it doesn't matter, but I'll be taking disjoint cycles, but it doesn't matter for our investigation. Now, I'll erase this part after writing this because this is easy. This thing, when you're conjugating this, it is the same as conjugating each of them separately. Right? Why? Because again, this is the trick. If you want to call it a trick, you can call it a trick. Is something which you use everywhere in algebra. Yeah, you see what I'm doing. And like this. Okay. So basically, there are two things. One is multiplying these cycles, and another is conjugating these cycles. And both the processes can be done interchangeably. First, I conjugate. First, I multiply the cycles and then I conjugate. Or first, I conjugate the cycles and then I multiply. It doesn't make a difference. Why? Because this is a conjugating, and conjugating is a group homomorphism, and so it commutes with group multiplication, right? Okay, but that is just I'm saying it in a stylish way that you might see in time, but this you understand by this concrete calculation. So if you can understand what this is, yeah, when sigma 1 varies over elements in Sn, then you are done, right? Then you can understand everything, the product. Okay, then you can understand this. Okay, product of this. Fine. So it is just enough to look at cycles. One more comment is, even we can, when I say it's enough to look at cycles, I also mean that, okay, let me write it and then I will say, this is clear. And that I will not even prove, that you should prove on your own. Or, I mean, okay, let me not even write. Let's leave that, not needed. So So here all these things I've said, we can summarize here by saying that sigma is a cycle. Okay. We'll just describe conjugates of cycles. So now it is very simple. So let sigma 1, I should first say what is sigma. Yeah, can I say that kind of thing without? Yeah, I can say. But let's calculate it and see. That's better, I think. Okay, let's not waste time. This is, and let's for the moment just take sigma 1 to also be a cycle. Okay. So far I've not done anything, right? I just written what is conjugacy and I've just started to calculate. You can just do this. Okay. And just calculating. Not use any theorem in group theory, like nothing. So now you just look at this. Okay. Just right. So you know that the cycle of this sigma inverse would be just this written in the reverse order. I'm sure you can prove that. Okay. If you know the definition of cycle. And if you are, even if you know it, still go back and do it. Okay. Check it. Yes. Because there are many interesting facts about permutation groups which one can prove and do even without knowing any theorems. So being good in these calculations is always helpful. Means you can never get good enough in these calculations. Just like matrix multiplication, the more you multiply matrices, it's not a waste of time. I mean, it's you learn some patterns which you don't realize you're learning, but later on it's very useful. Okay. So this is the situation. Now tell me what is this? Just tell me the final answer. Or yeah, see what happens. मम्मी थोड़ा खिड़की बंद कर दो ना. हाँ. Sorry.
You are taking sigma and sigma 1 to be disjoint, or it's disjoint, or like what?
No, that is not in my hands, right? Because sigma 1 is an arbitrary cycle and I have not mentioned that it is disjoint. Yeah. See, I'll tell you one thing. Disjointness is something which you finally want, right? When you're representing, when you're serving the final dish, it's like that, right? Then you want the disjoint. But while calculations, you cannot avoid becoming non-disjoint, right? Something like that. Yeah. Right. That's how I think.
Like you had given like B1 is going for B1 in last cycle, B1 is going to B2. B doesn't know where that middle A1 to AK, where does that B2 goes? Like if it is
So you're basically searching for a relation between these and these, maybe. Yeah, that is not given.
One thing I know,
Right.
that is, we can write it as sigma 1 of A1, sigma 1 of A2. That
Then
way.
prove it. Yeah, that I also know.
I know only.
Yeah, that is what you have to prove. I also know that. I don't know how to prove it. Yeah. So the final answer is this, and it's as nice as you can expect. But how do you prove it? It is just like a change in coordinates, right? It's just like everything in the world, I mean, 1 is getting replaced by sigma 1 and 2 is getting replaced by sigma 2. So
Actually, I don't know the proof, but if we take a smaller version of sigma 1 and sigma, then we can see that sigma of A1 will give some choices, sigma of A2 gives some choices, and we will get a right hand side that will be one more permutation.
okay. Anyways, yeah, I understand that. Yeah, let's see proof. I don't know how to prove this. Just think. Yeah. So I mean, just do it, right? So so when the element I comes, right? I mean, just do it. There's nothing. Just do it. So when I comes, then what happens to I? Yeah. Let's forget this. I mean, once you write the answer, it maybe becomes it maybe becomes simpler, but let's just do like this. Yeah. So when I comes, where does I go? So this one goes to sigma 1 I. Correct or not? Yeah. Here you see this thing is actually a distraction and completely useless, at least in the short term, right? Yeah, that's the problem I made. That's the mess I made in that sense, right? I mean, it is useless to write that. Sigma 1 I is what you get. And then you make a case, right? What else will you do? Sigma 1 I, you have to feed in this, right? So if sigma 1 I is equal to aj for some j, that can happen, or sigma 1 I is not equal to aj for all j. I mean, these are the only two cases based on which you will do something different in some sense. So if sigma 1 I is equal to aj, then what do you do, right? Then we get, I'll just make this a bit short. Sigma 1 I is equal to aj. So where will this go? This will go to aj plus 1, right?
Yeah.
Yeah. And right. And then we have to take sigma 1 inverse of this. So what is this? Right. So the I yeah, this is the answer, but we need to be able to write it.
If sigma 1 is giving aj to aji, then the inverse will give it aj1 plus j plus 1 to aj, I guess, because it's inverse. It will take backward once.
Yeah, but sigma, yeah, sigma 1 takes I to aj, right? But sigma 1 inverse doesn't take aj plus 1 to, yeah, that is not correct. Yeah. There are several other ways to prove it, but this should work. There is another way where we can claim that the answer is a cycle and then show that it is that cycle. All those things can be proved. But it See, the problem is that, look, this is the answer, right? But the problem is that we cannot describe this answer clearly. Maybe there's no, this is, I mean, this is what's wrong. This is the answer. Okay. But yeah, but we cannot see anything clearly. So we should, yeah, maybe we should look at something. If we look at sigma 1 a1 as the input and not I as the input. I mean, this is also an I, but it's a specific kind of I, right? Yeah. If you look at this as, I mean, sorry, yeah. If you look at, there's just a trick we have to play, because see, the problem is this. There is no problem, because this is the answer, but the point is you're not able to say what it is in terms of I. But what can you do? Yeah, that's how it is. Okay. But if you want to describe, then there are certain inputs on which the output can be described formulaically. Okay. So we look at those inputs, and those inputs are going to be, as you can guess, I'll take this. I'll start with this as the input. Okay, this is my input. Then I will apply sigma 1. Okay, this realization is what makes you start with this particular input, because you see that there is really no problem. It's just that you cannot describe it as a formula. Okay, then I will take sigma 1 of that, and I'll take sigma, and this is the definition. Okay. And then what will this be? Yeah. This will just be sigma a1, sigma 1 inverse. Right. Yeah. Oh God. Now what? So that is a sigma a1, sigma 1 inverse a1 should have gone to sigma 1 inverse a2, right? Yeah. So okay, yeah, that is what it is, right? Yeah. Sigma of a1 is a2, right? Yeah. I'm also getting confused along with you people. There is just a definition, right? Sigma of a1 is a2, right? So you see what happened. Okay. So if I call this sigma prime, okay, then this is just a calculation. Okay. Then we are getting, yeah, we have basically chosen on what elements to apply. We are just learning that sigma prime of sigma inverse. Okay. Yeah, or nothing, I cannot do anything about that. Of AI is equal to sigma inverse of AI plus 1. Okay. And of course, this I plus 1 is mod, I mean, this I is taken, this subscript is taken mod k, modulo k, because ak plus 1 is interpreted as 1. That's all I'm saying, right? So that you understand. Subscript is modulo k. Okay. Any questions so far? It's not completed. Okay. If there are any questions, just interrupt me. Okay. Otherwise, so far we have learned this. So far we have learned this. Okay. That you start with this k cycle, and when you conjugate, you get this. But do you get anything more? That is the question. You have to prove that you don't get anything more. So what does that mean? Yeah. So you see, if I have to spell it out, though I will not do it gradually, I'll lessen this spelling out. But this thing you see is just in from 1 to n, right? So I have described this, but you see, I don't know what this sigma prime does to other elements from 1 to n which are not of this form. I want to show that they are fixed. Okay, so I want to show that sigma prime of j. I want to show that sigma prime of j आवाज आ रहा है. हाँ. I want to show that sigma prime of j. No problem. So I want to just show that sigma prime of j is equal to j if j is not equal to sigma inverse a I. Do you people get my point? I need to still show this, right? Okay. I need to still show this, that other elements it fixes. Okay. Otherwise, how do I know? Okay. So this I will leave for you in for homework, or let's try it. I mean, let's do it. So here you can use some group theory to really, because this something, because think about it. This is something which is sort of a theoretical thing, right? So you can use group theory, but if you don't want to use, then you should do it directly. Let's do it directly. Actually, it's good to do things there. I think I made some mistake, right? Yeah, you guys should also tell, but yeah, I mean, I am making the mistakes, so I cannot tell you. This is sigma 1, right? Yeah, got it, right? Sigma 1, right? It's not sigma. Correct or not? Hello?
Yes, yes.
Right? That is sigma 1, yeah. So, right, yeah, otherwise it doesn't make any sense. So I need to show that this is fixed. Okay, so how do we show that? If you want to show it directly. So J, if J is not of this form, yeah, this is not difficult. So basically, maybe I'll say it on the other side, but basically it's like, yeah, so we'll meet after 10 minutes and then we'll do it. Is it sigma 1 is correct or is it not correct?
I think so. Like last one, it should be sigma 1 inverse of B I B I.
No, it should not be B, it should be A only. Yeah. It cannot be B. Anyways, let's check it on the other side, and then we'll also, some things are left that we have to describe it completely, right? Which